The Interplanetary Podcast. The exploration of space for the benefit of all mankind. Your hosts, here in London, Matthew Russell and Jamie Franklin.
The Interplanetary Podcast. Space. Where it's at. With Jamie and Matt. Last podcast, you suddenly come up with this question about boozing in space.
The drinking in space. Yes.
Turns out an unfeasible amount of booze has been drunk in space. Yeah.
But we thought it might just be the odd one-off.
No.
The odd Russian with some vodka in their spacesuit.
I have to say, you said something that was actually
genius.
Really clever.
Oh yeah.
When you said,
you look surprised.
No. When you said about the fizzing up,
The air bubbles.
And I
there
thought
is no gravity.
Yeah, and fizzy drinks are banned because there's this horrible effect because gravity doesn't pull the fizz down through your stomach.
Burp.
So you just end up. It just ends up getting sort of trapped up in your.
Sounds dangerous.
Yeah. I think it's not dangerous, but it's very, very uncomfortable.
Mm.
Basically, you can't. It just makes you.
Would you sort of need the Heimlich manoeuvre to get the gas out?
Yeah.
We should ask Tim Peake if he had ever had a Coca-Cola in space.
Yeah.
Or Pepsi. Both brands are available.
So, but what was really good about this drink thing is that the Russians on board the Mir space station, not only did they take alcoholic drinks into space, but it was their doctor actually said that they should take alcoholic.
What was his reason?
Well, cognac into space, but to stimulate their immune systems and to keep their organisms in tone.
Right, organisms in tone.
Yeah.
That sounds like they all surrounded this doctor and said, if you don't come up with a reason why we can take vodka to space, then we're all going to beat you up.
Now, what do you think the first liquid on the moon was?
I'm going to go with iron brew.
It is.
What a guess!
I can't get over that.
Guess.
Can't get over that. No, that is going to be when the Scottish, the Scottish bid to go.
Oh, for sure. That and Buckfast.
When Scotland has devoluted and has its own space program because suddenly they're rich beyond their wildest dreams because of devolution. They'll go to the moon, obviously.
What will you do without freedom?
What will you do without freedom?
No. William, what's his name?
No, that's how William Wallace spoke.
What
will you do without freedom?
Sounds a bit like Billy Connolly.
I thought it sounded a little bit like Shrek.
Sorry,
which is our
that.
second Mike Myers reference.
Yeah.
It was wine that was first poured.
Okay.
Because Buzz Aldrin decided to have a communion on the moon.
Right.
With wine.
That is nuts.
So not only did they take booze into space, it's also the first liquid ever to be poured on another body on the.
I wonder what wine it was.
That'd be really interesting to know. But I guess it was wine that was given to Buzz Aldrin by his local church. So it could have been. I don't know what is communion. I don't know what the usual communion wine is. Is it special wine?
What's the classic communion wine?
Well, what was the wine that Buzz Aldrin poured on the moon? It's pretty important. And when the Americans made Skylab, they had some chefs putting together the meals. And as we discussed on the last podcast, they had a chef putting together meals for the Skylab, and it leaked out to the press that he'd put sherry on the menu, and people went bonkers. So NASA have actually banned alcohol. There have been experiments brewing beer in space.
Shut up.
So, the University of Colorado brewed a tiny patch of beer in space and found that it had a much higher alcohol content.
Oh my goodness.
Others have tried brewing beer with yeast or barley. They sent up some yeast and they sent up some barley into space. And when they brought it back down, they then brewed beer with it. And that beer was known as Ground Control.
Tomatoes.
And of course, now that yeast has been up into space, with yeast, you just keep using the same yeast all the time.
Wow, that's amazing. Space yeast.
So there is actually a space yeast. So presumably you can go and buy Ground Control beer from the brewery Ninkasi.
Pint and a half, please.
Of Ground Control. So I'm going to try and see if I can hunt out
That is
some,
the next one. Have you ever tried
Ground Control?
Ground Control beer?
Yeah. A Japanese distillery sent up one of their whiskies to the ISS to find out whether zero gravity influenced the flavour.
Oh, what did Mr. Hadfield have to say about that?
Mr. Hadfield took up some whiskey and he said, "This will truly demonstrate the discipline and self-control of astronauts." He wasn't allowed to open it.
Oh, really?
So he took it up and then took it back down again.
Oh, man.
Oh, what? When private companies go into space, of course everyone's going to be there with their little glasses of champagne going,
Yes,
look out the window, I can see the thin blue line of the world's atmosphere.
Is that what they're going to talk like?
Yes, I think it is. And these experiments are going to be quite handy to see what to take. And now they know, of course, not to take beer.
Yeah.
Because it will froth up in their tummies.
This is it. You live and you learn.
So carbonated beverages completely off the menu.
It's quite an exciting podcast, this one, because we're about to discuss something that's the most exciting planet story that there's been in the last decade. Is that too strong?
When was the first exoplanet really discovered?
Good question.
Yeah, 1988. Exoplanets were confirmed. Until then, scientists didn't know whether the stars had planets around them, whether our situation was unique. Isn't that incredible?
Now, how they actually discovered it was through a bend in its star that meant it had something orbiting it. Am I right?
You are right. Now, so the thing that's been discovering most exoplanets, and that's now 3,500 exoplanets or thereabouts have been discovered since 1988. Most of them have been discovered by the Kerbal Space Telescope.
Yes.
And what that looks for are little dips of light.
Yeah.
So the planet goes in front of the disk of the sun and there's a little dip of light. Now that only works if it just so happens that the planet's orbital plane is where we're looking at it. And most of the exoplanets we see are the luck that those particular stars have orbital planes that are totally in line of sight where we're looking out.
Now the telescope used, what's the name of it?
It's the European Southern Observatory, is that right?
Correct. But apparently they didn't have the funding for the EELT. Now the name of this is so ridiculous that it's great. European Extremely Large Telescope. I mean...
And so instead of looking for this dip in light, a lot of the ground-based telescopes are looking for something different, which is the wobble in the star, which is what you alluded to earlier on.
So that's indicating... Well, it's indicating something orbiting around it, potentially.
So basically, all objects, all of the solar system, for example, all the planets that are orbiting the sun aren't really, strictly speaking, orbiting the sun. Everything is orbiting each other. It's just the fact that the sun is so massive, it really, for all intents and purposes, we're all going around the sun, with the exception of Jupiter. Jupiter's so massive itself, the sun and Jupiter orbit one another because the centre of their orbit lies outside of the body of the sun.
Right. Right. Just to be clear, are you saying that Jupiter should go on a diet?
Yeah. Jupiter's well fat.
Cut out the donuts, bro.
So what Earthbound telescopes like the European Space Observatory Extremely Large Telescope look out for is this wobble. They spotted this wobble a long time ago, I think. 2014,
I believe.
When you do the maths of what's causing a wobble, etc., etc., it turns out that you have a planet that is really very, very exciting.
So, size-wise, they reckon it's, I think, is it 40 or 60% larger than Earth?
Isn't it 1.3 times bigger than Earth?
Right.
What is absolutely incredible is Stephen Baxter, the sort of really well-known sci-fi writer, wrote a book called Proxima. He pretty much nailed it. He'd obviously done the maths that Proxima Centauri, being a red dwarf star,
yes,
the planet needed to be very close to its parent star to actually be warm enough to be in. And now here is the exciting bit about all this. It's in what the scientists call
habitable zone.
The habitable zone.
Okay, so habitable zone. So that was one of my questions that I had for you. Now, the habitable zone, it's actually quite close to the star. They're still saying that they can't tell what the atmosphere is like, of course, and whether it's freezing or whether it's hot. They can't tell any of these things until we send a probe there. Is that right?
Well,
could we tell that if we have a strong enough telescope?
If you have a strong enough telescope, what's really annoying, we're back to this thing where it's not in our line of sight. One thing you can do with very powerful telescopes is look at the dimming of the star and actually be able to see the atmosphere. The starlight goes through the atmosphere of that planet, and you can pick up chemical traces as the starlight goes through, because the chemicals in the atmosphere will create banding in the sun's spectrum. Right. So you can actually see how that atmosphere is made, but we don't have that luxury with Proxima B because its orbit is not in the same plane as our line of sight.
And actually, talking of the orbit, I heard one scientist say that there's a very good chance that that Proxima is tidal locked with its star, which means that, for anyone who doesn't know, that means that the same its face is constantly one-sided, getting the rays from the star, and then one side is completely in darkness.
Yeah, well, and we
so
have
if the sun would have to be hot enough for it, if there was oceans, for it to be liquid on one side and the other.
Tidally locked, if you want to see an example of a tidally locked orbital body, you only have to look at the moon. And when you're very, very close to... So
that's why we only saw the dark side of the moon when we sent a probe round.
That's right. That's exactly right, because it's tidally locked. So we can own... And of course it looks very, very different, because that side of the moon is exposed to many more impacts from comets and stuff like that are heading towards the gravity of the Earth.
Let me stop you there. I've suddenly started to get worried about something. When we colonise Proxima B, which I mean obviously is going to happen, it's going to cost us a fortune in birthday presents. Because every 11.2 days,
everyone has a birthday.
Everyone's going to have a
People are going to live to be 20,000 years old or something.
I mean...
That's annoying, isn't it? Actually,
we're going to have a new system because...
Well, we'll have to call the whole thing off, I think.
Yeah.
Here's an interesting thing, though. So, it's tidally locked. Well, it doesn't necessarily have to be tidally locked, because here's another thing. Planets that orbit around red dwarfs are... until recently, scientists have thought actually it's a really bad thing, because what happens is red dwarfs are quite angry stars. They flare up and send off these coronal mass ejections all the time when they're young. So for the first 2.5 billion years or so,
youngsters.
When they're young, they're very angry youngsters. Unlike our
adolescent,
they're very annoying adolescent stars. Unlike our sun, that's always been quite kind of mild and caring for its planets that go around.
It's kind of middle age, isn't it?
No, it's not middle age. It's still very young.
We've still got 5 billion years of the sun.
No, we've got way more than that.
No.
Yeah. No, it's about 5 billion years old, and we got about another 15 or something.
15.
Whereas Proxima's actually got a lot longer because now it's gone through its angry youth phase. The Proxima Centauri should last a lot longer because it doesn't burn through its heliums, it doesn't burn through its hydrogen as quickly as our star does. It can sip on it for a long time. But it's been an angry star up until now, for the first 2.5 billion years. So while Earth was while life was springing up on Earth under its gentler conditions, Proxima B would have been battered with ionising radiation from its star.
So, is there any way, because of that knowledge, that we can tell the surface is definitely going to be...
No. So here's if you think about our own solar system and you thought about looking into it, you'd not be able to tell. Bear in mind, we've got 3 planets inside our habitable zone. The Goldilocks zone, not too hot, not too cold, named after Goldilocks' porridge. So it's and basically it's not too hot that water turns into steam and escapes the atmosphere. It's not too cold that water turns into ice. It's just the right temperature for water to be liquid on the surface. Now that is what it's all about. That's what the habitable zone is all about. And actually, recently they've decided that really there should really be 2 habitable zones, because in our solar system there's plenty of water that's liquid in other places outside of our habitable zone, like Europa and places like that. Even Pluto might have liquid water, it would seem. So, we've got 3 planets in our habitable zone.
Yeah.
There's Venus and Mars and Earth. And how different are they? Venus has had a runaway greenhouse where it's held onto its atmosphere. It's got thicker and denser, and it's full of, and it's just heated up to an insane temperature, and the atmosphere is so thick and dense that it crushes everything that's in it. So it's completely inhospitable, pretty much close to hell on Earth. Yet it's the same size as Earth, and it only orbits a little bit closer to the sun than we do. Mars, on the other hand, for some reason lost its magnetic field and therefore lost its atmosphere, and has become a barren planet. There's Proxima. You've really got no idea whether it's going to be more like Venus, whether it's going to be like Earth, or whether it's going to be like Mars, or some other variation. I mean, this is the thing, we've only got 3 planets that we've ever really known in habitable zone that we've kind of looked
and that's
at.
in our solar system.
And so we've got out of all the maybe millions of possibilities, we've only seen 3.
Well, here's the thing. I think everyone's getting very excited, obviously, about Proxima B. Let's speak.
Well, let's speculate. Let's do a bit of speculation
about. Okay, let's start off before we get into colonisation and all that stuff. Let's speak a bit about getting a probe there. Matt, is it 4.3 light years away?
4.22 light years away. 4.3, I think, is to Alpha Centauri.
Yeah, that's what I said.
To the Alpha Centauri system. So Proxima's a little bit closer. See, this is the amazing thing. Proxima is our closest star.
Yeah. Not that close, but close.
See, this is what makes this discovery so amazing. We will never find, ever again, an exoplanet as close as this one. This is the closest exoplanet there could be.
Yeah.
That's what's so ridiculous, the fact that it's in the habitable zone. That's what makes this such an exciting thing. Not only that, I think it's really exciting because it's in the last 20 years that it has become feasible to actually send something out that far.
That's right.
And so when I say feasible, I do put that in very much inverted commas, wiggling my fingers around.
Before we talk about feasible and we talk about the probes, can we define habitable zone? Because we still don't know what the atmosphere is like on this planet.
Habitable zone is literally defined. It's the same as Goldilocks zone. So it's not too cold and it's not too hot for liquid water to be on the surface.
Right, so that's what it means. But, it's just about liquid water.
But if the planet has an atmosphere, then it will be around about 30 degrees centigrade on the surface, if it has an atmosphere. But if it's lost its atmosphere, and which is very, very likely, it's very, very close to its star that's ravaged it with solar winds, and it could have had its atmosphere ripped off. Now, the only way that might not have happened is if it's got an extremely powerful magnetosphere that protects it from the sun's rays. There's another possibility, is that the planets in our own solar system may not have formed in the positions that they are in now.
Right.
So there is a possibility that Proxima Centauri had a very large planet orbiting near it for the first 2.5 billion years, and due to some orbital effects, a rocky planet that formed a lot further out has slowly migrated in.
Right.
And therefore it wasn't exposed to all this hideous radiation, and it didn't lose its atmosphere. So there's a few possibilities that make it possible, and it might have maintained its spin, so it might not be tidally locked as well. So there's a few possibilities here that it's okay. And not only that, of course, if it is tidally locked, there might be a band of the planet that is just the right temperature for liquid water still.
So what if there's this band that is the right temperature, and there's liquid water in that band?
Well, there's two possibilities. Then is liquid water that life has sprung up in there, or that water has been so irradiated that the planet has been made sterile.
Imagine if we got there and we could only live on like 1% of it.
Yeah, but 1% of the band of a planet that's 1.3 times the size of Earth is actually there's a lot of real estate. But not just that. It's more.
You're already selling houses on it.
Yeah,
Chill out.
I know, but it's more the fact that if you could get there and you could prove that life had started up there, it changes everything. But then maybe we're better off looking for that in our own solar system, or even on Earth itself. If we were to think about going to Proxima Centauri, so we've got 4.2 light years to get there. That's 25,000 billion miles.
Yeah.
So just to make that extra clear, that's 25 million times a million miles away. It's a long, long way.
Yeah, you
away,
can't.
Right?
You can't route map that.
No, it's an insanely long way away. Now, if you were to travel at the same speed as, say, the space shuttle went at full whack, it would take you 165,000 years, right?
165,000 years to get there.
Yeah, so as a manned flight, liquid fuel rockets are pretty much out of the question. And you say, well, why don't you just build a liquid fuel rocket that becomes so fast that it starts to get up to some decent speeds that means that we get there quicker? And the answer to that is, if you use the famous rocket equation, it turns out that the amount of fuel that you need, mainly to carry the fuel of the fuel that you need, to get it to Proxima Centauri and to slow down, would mean that you would need a fuel tank the size of the observable universe.
Okay. All right. Listeners, you may need a few minutes just to let that settle in.
Yeah, it's
so
big.
Matt, are you saying
it's a non-starter?
Are you saying that I couldn't travel there in my lifetime?
There is another way of doing it, and that's, like we said on the last podcast, is having small particles that come out extremely fast, rather than just at rocket blast fast. You have them coming out.
Is this ionic propulsion?
No, well, ionic propulsion won't do it either. Ionic propulsion won't get you anywhere near that kind of speed. There's just not enough energy to push you that far at that sort of at any kind of decent speeds. So ionic propulsion, it's all very well and good to sort of go round the solar system on, but it still doesn't really get you up to any kind of significant speed.
All right, let me throw some at you, and I only want you to reply in a sentence if it can or can't happen.
Mm-hmm.
Nuclear thermal propulsion.
So, if you wanted to get there as a manned mission, I think that's your only bet. So fusion rockets, there's a couple of there's a few options here.
Okay.
So the Americans looked into this, And one of the physicists involved in this was the famous Freeman Dyson, who's also famous at the moment for his Dyson Sphere Tabby Star.
The Dyson Sphere.
Dyson Sphere Tabby
We'll post up a link about that, and so your head can hurt as much as mine did last night.
So anyway, Freeman Dyson was involved in a thing called the Project Orion. And there've been lots of Project Orions, but this Project Orion was a nuclear fusion rocket ship, which basically dropped nuclear bombs behind it and sort of powered it along on the sort of surfing the wave of the nuclear blast, essentially. And there's some fantastic YouTube clips of sort of test models being sort of flown up in the air on the back of shockwaves. You know, and it theoretically works. I mean, if you were to go to Proxima Centauri on a Project Orion that was kind of fully working and efficient, you'd need about 300,000 1 megaton H-bombs. When I talk about the other options, you'll see that actually that's not too ridiculous. The problem is you're building 200 times the nuclear arsenal that's already on the Earth, which is already ridiculous. But the good thing is we know how to make nuclear bombs. Yes. So we actually know the technology is there, so it's actually there. But actually, if you use that amount of explosive, the journey would take 90 years. So 90 years... as a human spaceflight, that still means you've got at least 2 generations of human on that spaceship. Yeah, there's a couple more fusion rockets that are of enormous interest to me, and one of them's Daedalus. Now, Daedalus in fact, it still remains really the only project that has been looked at from beginning to end and had a full feasibility study on it of an interstellar flight. And it was done by the British Interplanetary Society. That has on-board contained fusion. It's extremely difficult, but it is possible. They've done the feasibility. It all, on paper, looks like it'll work. Now, recently, they decided that they would have another project called Icarus. And Icarus was launched by the British Interplanetary Society again in 2009. Uses a new type of nuclear fusion that's been ignored for a while, Z-pinch.
Correct.
Is that right?
Now, if I'm right, Matt, the Z-pinch is where you've got energy going into a tube, and instead of blowing up that tube, it compresses the tube, and therefore matter comes out the back of it very quickly. If a bolt of lightning hits a pole, it doesn't blow that pole up; it contracts that pole,
and that causes the nuclear fusion.
Yeah.
Forces the nuclei to fuse with one another, thus releasing the strong nuclear force.
Yeah, that's what I said.
Yeah, nice. Yeah. And what's great about that is that they've worked out it can get up to 1% of the speed of light.
Not too shabby. I was hoping for more, but
it's enormous. I've put a picture on Interplanetary Podcast Instagram of how much bigger it is than Saturn V.
Yeah, it's pretty big.
It's massive, but not as big as Daedalus was. And it looks like a dart.
Do you think they'll ever, just for a laugh, make one in the shape of, I don't know, dog or something? Like a banana?
Or what's that man holding the pizza in Austin Powers?
Yeah.
I think they're really concentrating...
Probably got bigger fish to fry.
Yeah, they're concentrating on the technical issues.
Definitely will be a big fish. So, Matt, I'm going to say 2 words to you. Laser sail. So if we're sending a program to Proxima B, do you think this should be it?
Well, the laser sail doesn't have to carry its fuel, which means that we can forget about the rocket equation. We can forget about large vehicles carrying loads of fuel with complicated nuclear fusion going on, etc., etc. And we can have, what we need is to fire an incredibly powerful laser at a sort of large sail that has a small 1 gram spacecraft that you blast towards Proxima Centauri. Now, this was something called originally was called Star Wisp years ago, and has been recently kind of reignited by Stephen Hawking, etc.
Bless him.
To the Breakthrough Starshot, which we talked about on the second ever podcast. And obviously Breakthrough Starshot has had a load of publicity again, because it's essentially, a lot of people are seeing that, and I personally think that if anything is going to get there, it's probably this, in terms of a small probes being sent out an absolute swarm of these things, these vast sails going 4.2 light years, going very, very fast. A lot of them are going to get destroyed by dust on their journey, but some of them might make it. The problem is slowing down. So all these are going to be flyby missions going very, very fast, but at least we'll get some information back.
So it could be accelerated to 20% of light speed, making it possible to reach Proxima Centauri in 20 to 25 years.
Yeah.
Now, how much would it cost to do this?
Obviously very expensive to build this laser array, and the one thing that's easy to brush over is this laser array is a phenomenally powerful weapon.
Yes.
So
you wouldn't want it to get into the wrong hands.
You'd have to be very careful about how this is financed and how this is built and who has control over this enormously powerful thing.
Well, there's it's Yuri Milner has announced $100 million for research into the 20-year journey of the probe.
Yeah, I mean Yuri Milner is the Starshot guy, and he's already stumped. Yeah, he's just a multi-billionaire who's been stumping up this cash, and got Stephen Hawking and a few other. In fact,
I like Yuri.
Yeah, I mean,
if you're going to put your spare cash in something.
But I have to say that this has been looked into less than the Icarus Daedalus. You know, both of those have had a lot of work done on them. So don't rule out that Daedalus or Icarus projects will be the way that we do it, because the light sail thing is still an unproven technology, and not enough research has really been done on it. But if I was a betting man, I'd say that is going to be the thing that gets to Proxima first.
Yeah.
Now, there's a couple of other scenarios that we haven't talked about. There's the antimatter drive.
Oh, what? The AMD?
The AMD.
Yeah.
Yeah, AMD. Because fusion. I'll see. One of the downsides of fusion is E equals mc squared. Energy is mass. It can be you can convert mass into energy, and when you do, it's a hell of a lot of energy. Fusion, however, only turns 1% of your mass into energy, whereas an antimatter drive pretty much converts the whole lot. You know, a hell of a lot of energy out of a small volume of fuel. The problem with that, of course, is that to make antimatter is incredibly difficult. At the moment, we only really make it in the Large Hadron Collider and a few of these other particle accelerators.
So we would need quite a bit more.
Well, we need to expand our production of it by 100 to the power 24.
Okay.
So that's 1,000,000 times 1,000,000 times 1,000,000 times 1,000,000 times 1,000,000 times 1,000,000 times 100
I feel sick.
times more.
I'm going to throw up.
And then we have enough antiprotons. But how on earth do you contain antiprotons? If you build a container, these antiprotons will annihilate the protons in the container. So you have to contain these things. So actually, containing antimatter is harder than making antimatter.
Would it be like one of those jars that they have the squids in?
I believe that
with crabs.
Well, however, they did it in that stupid book by Dan Brown.
Oh yeah.
However they did it there.
Yeah.
So we'll just have to phone up Dan Brown and ask him how he did it. But anyway, antimatter drive, we get up to 0.8 times the speed of light, and then time dilation kicks in. Get in. So a journey that looks to us took about 13 years only took 4 years for the people on the antimatter spaceship. Genius, huh? Now, do you want to hear the last few crazy suggestions?
Here we go.
So there's the black hole drive.
Oh yeah, I like it already.
The Schwarzschild Kugelblitz.
Okay.
So Kugelblitz means ball lightning. And if you can crush enough energy into a very small area, you can create a microscopic black hole. It's what Stephen Hawking's theory of black hole radiation, which was made in one of the most famous scientists in the world. So it turns out that these Schwarzschild Kugelblitz black holes.
Oh yeah.
There's a kind of little sweet spot. So if they're too big, they're going to be too heavy for the spaceship, and if they're too small, they evaporate off too quickly.
Okay.
Right? So you can get a certain size of black hole, and it will be roughly the size of a proton. Imagine that, the size of a proton. Well, it's hard to imagine because a proton's very small.
It's not that big.
But that proton weighs the same as 2 skyscraper buildings, right? And has the power output that's 10 million times that of the yearly power consumption of somewhere like London. Way over.
That's hard. It's hard to get your head around.
So this thing is a little tiny dot that you can, but we can't see. You can't see this thing. It's so tiny, yet it's pumping out that much energy. Can you imagine that? No. So anyway, this thing could then power your spaceship. It's actually what the Romulans use in Star Trek.
Oh yeah, I know that.
It turns out the Carl Schwarzschild Kugelblitz is what's used in the in Star Trek.
I'm more of a Star Wars guy, but carry on, Matt.
Yeah, but I'm just doing it for the Star Trek listeners amongst our many millions.
Geeks.
But there's a few downsides to this. Isn't the fact that the lasers need to be more powerful than the black hole that you've just made. So there's a lot of energy just to make this black hole in the first place. But it's theoretically possible.
Yes.
There's other crazy tech like the EM drive. Completely, no one knows what the heck's going on there. Very controversial. Wormholes. Who knows? And of course, every sci-fi fan's.
I know what you're going to say. AD,
the Alcubierre drive.
Oh, that's one of my fave drives.
So Alcubierre drive is basically where you warp space-time itself and ride the warp of space-time through space. So you can actually get faster than the speed of light because you're not moving faster than the speed of light. Space-time itself is just being warped in your way, so you're not moving. I
think I once rode the warp in Ladbroke Grove in West London.
Okay.
But it was just a very quick journey home on the bus. Let's move on.
So anyway, there's the list of things. So what do you think after having listened to all the ways that we can get there?
So personally, I mean, as you know, Matthew, I think we're very different in the way that we see things. Mm-hmm. I get very excited and I just start thinking about the romanticism of colonising an Earth-like planet. I really want it to have mountains and seas that are fresh, that we haven't mucked up. Bloody humans.
Oh, humans are ace, Jamie.
We're great, but can we just chill a bit?
Yeah, we should chill a bit, mate.
You know what I mean?
Do you know what I think's quite good? I quite like Carl Sagan was a little bit like this, where in some ways the journey of our mind can be just as good as actually going there.
I hear that.
Another famous British Interplanetary Society member, Mr. David Hardy, very famous sci-fi artist, did a painting in 1972 called The Challenge of the Stars, and he did it with Patrick Moore, and it's of a planet orbiting Proxima Centauri.
No way.
And you can even in his painting you can even see what the constellation of stars would look like just behind.
That's incredible.
Yeah.
So was Patrick Moore giving him tips on what?
Yeah. and they did this thing. And
well, ironically, you were just talking about Carl Sagan. He obviously very famous for the pale blue dot, which is us. And this project that the ESO found was the pale red dot.
That's exactly right. Obviously, as a tip to the hat to Monsieur Sagan.
Matt, do you like that I've done my research for this podcast?
You absolutely, totally have.
Yeah.
Safe, bro. So, yeah. How exciting is that?
It's really exciting, isn't it?
So,
I mean, all of the negativity aside of, we're not going to get there for a billion years, whatever. We're working on things every day.
People
that
have
are getting us further. New technology.
Here's something that you should never listen to. Is anyone about anything. Albert Einstein, when he postulated about gravity waves,
good word that,
said, gravity waves, it's a thing, but it's going to be so tiny we'll never be able to measure it. Right? We'll never be able to measure it. And within 100 years, we've managed to detect gravity waves. So there's loads of exciting things about this. Absolutely. Can I tell you something that I really, really like? And actually, I mentioned this on another podcast that we did. And I thought it was my own idea. And it turns out that this is a sort of well-known thing. Oh. So the weight equation, the weight calculation. Yeah. Now, the weight calculation was introduced by Andrew Kennedy in a paper in the Journal of the British Interplanetary Society in JBIS.
Yes.
And it describes how... Remember when I said, imagine that you go on an interstellar mission. Say we build this spaceship and off you go on your 90-year mission to Proxima.
Yeah.
And then you get there and there's already people there and they go, yeah, when you were gone we developed a new spaceship and it got us there quicker.
Yeah.
So...
That would be frustrating.
Yeah, so someone said what would happen is that people would always... go, let's not build it yet because in a few years' time we might have another technology that means we'll get there quicker.
Yeah.
But what Andrew Kennedy did is he put this into a mathematical equation called the weight calculation. And the paper describes how civilizations may delay interstellar exploration as growth will continue to progress and find quicker means of travel, overtaking them to reach a destination first. But using simple equations of growth, it can be shown there is a time when the negative incentive to travel turns positive and where departures will beat departures made at all other times.
Okay.
So it's a really brilliant piece of work because it means that actually, no, you shouldn't. There's a point where you shouldn't wait any longer and that you've just got to go, right, now is the time. Now is the time to do this.
Let's go.
So what's brilliant about it is that Andrew Kennedy has given impetus to actually do this. No, let's just do it. Let's go out there and do it. Let's not wait for the technology to get better. Let's just
all that technology. You would have thought that they've just got a little radio that they can say, guys, just so you know, we have found technology that will get us there quicker than you, but we're not going to do it. So just carry on as you are. We'll put that technology into making sure that you get there safely.
Well, do you know what's really annoying about that? It's like your radio. What speed does your radio signal travel at?
Oh,
See? It's so annoying, isn't it? That interstellar distances are so vast, you can barely believe it.
All right, we'll send a light-sailed telegram then.
So a light sail goes off, gets up to speed, then it does a flyby, then it... so you might do that in 45 years, then it takes 4.5 years to get the signal back, and you go, I'm dead. So all the scientists that built this light sail we've gone.
I want them back.
A Japanese astronaut is known as an astronaut.
Slightly less interesting than I was hoping for.
There are a lot of names for astronauts.
Give us a few of them.
Right. So we have cosmonauts, obviously,
which is
Belarusian, Bulgarians, Cubans are cosmonauts, Czechoslovakian cosmonauts, Kazakhstani cosmonauts, of course.
My favourite one.
Mongolian cosmonauts.
Oh, hang on.
But there's a few funny ones in here. You've got things like French are called Astronaut? No, they're called a spationaut.
Oh yeah,
Spationaut. Indian were called cosmonauts, but they're going to call them Vyamnauts soon.
I like that.
Vyamnauts.
Nice.
So yeah, there we go. So there's a few nomenclature there to remember.
Well, we've answered our questions.
Yes, but yes, it was a trick question. Japanese astronauts are known as astronauts. 6 major rocket launches, 3 Long March,
Yeah.
and Ariane 5 right at the end,
Yeah.
which did a couple more Intelsats. But my favourite one was a Chinese launch that had a quantum satellite on it.
Nice.
So this quantum satellite is going to be able to send entangled quantum data to and from a Chinese and I believe Dutch centre. So it's basically all about encryption. Now, if the Chinese have nailed this, it means that they will have the safest data network ever.
Wow.
Because the great thing about entangled particles means that if they send a piece of information somewhere, if anyone intercepts it, they'll know that it's been intercepted because it will collapse the probability function of the entangled particles going to the master station.
Right. Okay. So anyone thinking of...
You can't eavesdrop without being found out that you've been eavesdropping. You can't even eavesdrop in the future, it would seem, from the double slit experiment with the mind-blowing scrambling
God, what
thing.
can we do?
Well, so the Chinese might... I think it's one of the most
Are you
interesting...
saying I can't hack computers anymore, Matt?
It might mean that you can't hack Chinese computers.
Just Chinese. Well, that's all right.
The Chinese are taking a march on us all. A long march.
Good. Really good.
Yes. So yeah, that was I thought that was one of the interesting things. Another one that was interesting is that SpaceX Falcon 9 had flown up, and it was its second chance of doing this, and this time it was successful. Ida 2. Remember what that was from the last podcast?
Ida 2?
Yeah.
No.
It was the International Docking Adapter.
Ah.
So the International Docking Adapter...
The IDA.
Yeah, was flown up on the SpaceX launch from last month. But it was being fitted to the International Space Station. And the 2 astronauts that did it were the 2 astronauts that flew up... Well, other than the Japanese astronaut, the other 2 was Jeff Williams and Kate Rubins.
Yeah.
Jeff Williams is now the 2nd oldest person ever to do a spacewalk. Kate Rubins and Jeff Williams did their spacewalk, and it was very, very successful. They spent 5 hours. They were always ahead of themselves and managed to do a whole bunch of tasks that were kind of follow-on tasks if they had time to do them.
Yeah.
So they managed to install the new IDA. Now, what's fantastic for Jeff Williams is he's not only the 2nd oldest astronaut now to have done a spacewalk. He's also America's. He now holds the record for the most days in space by any American astronaut.
Wow.
After we criticised him, Justin Young actually did get his act together and send me some ideas for slogans.
Oh, he did?
He did in the end.
Oh, my goodness.
I know.
Well, I'm dying to hear them. Justin, there's a lot of pressure on you here.
There is. Particularly the way I'm selling it. Shining a light into the corner of spaceflight.
Not bad.
Space, where it's at, with Jamie and Matt.
I like it. I like that. Right.
Yeah.
Okay.
Shining a light into the corner of spaceflight.
Pretty good, but definitely the latter.
Yeah,
is my
space, where it's at,
with Jamie and Matt.
Yeah. I don't like the fact that you came first there. I think it should.
Oh, okay. Is it just innuendo?
No. It's that was a bit lamey because it wasn't Matt and Jamie.
Oh, God. I'm worried now that he's put these puns into your
These
head.
have become a bit samey.
With Matt and Jamie. No.
No.
Let's stop there.
That smells a bit gamey. with Matt and Jamie.
Yeah, it's the G&A show.
So I've got two young men have joined us for the last part of the Interplanetary Podcast. Now, can you both say the Interplanetary Podcast putting the ace back into space? Go.
The Interplanetary Podcast putting the ace back into space.
Yeah.
Perfect.
Do you recognise the voice? It is the voice of the Interplanetary Podcast. So, guys, apparently you've been playing Kerbal Space Program.
Yeah.
What? So can you give me a review about Kerbal Space Program?
It's really good. Compared to other sandbox games, it's really realistic. It's quite like detailed, because you can basically make whatever you want. You can make planes, cars, boats, rockets, and Spaceships are also.
Oh yeah.
Yeah.
And what are Kerbals?
Kerbals are like the people basically.
Oh.
And Kerman's Earth.
Right. Okay.
Kerbal. Wait. Yeah.
Have you
Earth.
have you actually managed to get anything to orbit?
I have accidentally when I was trying to break this airspeed record.
Okay.
We've all done that.
And Arthur, what have you made anything exciting in?
Well, I've made this thing that blew up the entire track
Oh
for
no!
the planes.
Oh god.
Well, that's pretty easy. to
Cool
do, actually.
security.
And what have you been doing this evening?
Oh, we've been building rockets.
Yeah, but
There we
what in
go.
Kerbal Space Program?
No.
real life.
Real life rockets.
What?
What have you been doing?
Oh, we've been building model
rockets. Nice.
That work.
That work. Oh, nice.
So how quickly are they going to get us to Proxima B?
In more than the universe has been
More
around
than
for.
Well, I'd like to sign up. Don't know about you, Matt.
Yeah, no, let's sign up. If we can get on that, and it'll take us over 13 billion years to get there. Whereas, look, if we live that long,
Yeah,
that'll be
that's
alright.
true.
The other thing about living for 13 billion years is that we'll have tried everything, and then we'll be sitting around going, oh, we've kind of done everything.
Bit bored now.
Bit
yeah.
bored.
Matt, shall we read the boys our new tagline? See what they think.
Yeah,
Test out.
Okay, yeah. Which of these taglines do you like? Do you like the Interplanetary Podcast, shining a light into the corner of spaceflight?
Well done. That's good.
Is
Yes.
Pretty good, but wait till you hear this
Alright.
one.
The Interplanetary Podcast, space, where it's at, with Jamie and Matt.
Yeah, see,
That's
Yeah.
an amazing one.
That's
right?
the one, isn't
That's,
it?
Yeah.
that's the one. That's
Nice.
the one.
That's the one. Sign him up.
And is it better than the Interplanetary Podcast? It's not rocket science. Not.
Oh, that's difficult.
It's not good, is
Oh.
it? It's not good, is it?
Oh, that's an ace one. And what was
Yeah,
your
yeah.
one, Jamie? They used to think that space was all samey. The Interplanetary Podcast with Matt and Jamie.
No, this is a better one.
No.
They used to think the
Copyright.
Earth was flat. Jamie's the best, and then there's Matt.
Well, that depends on point of view.
That's true.
Oh,
yeah.
see?
That
Yeah.
is
You
true.
can always count on Arthur to stick up for his dad.
That's true, Arthur. Don't worry.
Yeah.
Arthur, how much? Stick up for me instead.
Oh, and thank you ever so much for all the Interplanetary Podcast Twitter followers.
Yes, we got some big action going on Twitter. Matt, for those who aren't on Twitter, how can they follow us, and what's our tagline?
Our tagline on Twitter.
When I
is,
say tagline, I just mean what's our at?
what's our at? Yeah, what's our Twitter handle?
That's the one.
Is it Twitter handle? What do you call it?
Handle,
Count.
I think.
Account.
Sure, account name.
What's your account name? Interplanetary Pod. Remember, you thought I'd said it wrong last time.
Yeah, you didn't though, did you?
But I think your best bet is to go to interplanetary.org.uk, and all the links are on the homepage there. So you've got
all the links.
You got all the links. You got our Twitter feed, Instagram, Facebook, Tumblr, SoundCloud, iTunes, Stitcher, and TuneIn.
So Matt, that website once again.
Interplanetary Podcast. No, do it again.
Okay, Matt, that website once again.
Interplanetary.org.uk.
Medication time.
Arthur, play your song on that, and listeners, what's that noisy? Go. Nice.
Real good.
So email in Matt at interplanetary.org.uk and tell me what song that was played by Arthur Russell. Not Arthur Russell, the New York folky artist.
Who is genius.
Who was genius.
Who did my favourite song of all time called What It's Like.
Right, there you go. And not George Russell, the inventor of modern jazz. Thank you very much, everyone, for listening. And thank you very much to our guests, Arthur Russell and George Russell.
Big up G&A show.
And yeah, if you get the chance, download Kerbal Space Program because it's actually brilliant. See if you can see an up-and-coming launch and make an identical rocket and see if you can get the profile exactly right and then set it off at the time that the rocket launches and see if it follows the exact launch profile of the launch. Apparently it's possible. I've heard an interview with the writer of Kerbal Space Program and that's what he does.
Hands up if your mind's blown.
My mind's blown.
We're all hands up.
We're all handed up here.
Even though I played it.
Okay.
Thanks, guys.
Thanks.
We'll see you next month for podcast 7.